I'm Chelsea Zaccato.
And I'm Natalie Heacock.
And this is Lumber Slingers.
Each podcast, we will be bringing you relevant and useful industry information, including interviews with top lumber professionals and discussion of current events in the industry.
Whether it be lumber grading, industry and market trends, or who's who in lumber, we hope to extend your current tally on industry knowledge.
Welcome to another episode of Lumber Slingers, Chelsea.
Hello.
Hi, how are you today?
I'm great. You know, we're winding down at the International Mass Timber Conference, and boy, it's been a great show, and we've met some really cool people working on some really cool projects.
We really have. And we have one of those people here today. We are joined by Judith Sheine. She's a professor of architecture at U of O and the director of TallWood.
Director of Design for the TallWood Design Institute,
which we're going to get into, which is very exciting. So, and we walked by your booth earlier too. We'll have to talk. If you want to call it a booth, it's more like a research
demo area.
Research demo area.
That's what we should be calling everything.
Yeah. We've been calling everything booths, but they're not really booths.
There's no booth out there.
Yeah. So we wanted to go back to basics and start from the beginning. And our very first question is, what is mass timber?
Mass timber is a form of engineered wood product, and it's made from small pieces of wood, either small pieces of lumber, 2x4s or 2x6s, or chips or strands that are fastened together generally with glue, but sometimes with other things like nails or screws or hardwood to make big, strong components. So instead of, the old way of doing lumber where you chop down a tree to get a very big piece of lumber, these are engineered to actually use very small pieces of wood of lots of different kinds to make very big, strong structural components out of wood.
Wow. That's like the best answer.
I know. That was like, oh, okay, I get it now.
Yeah, I can't take credit for it. We've been writing grant proposals and trying to explain this, and several of us, I think, have honed this explanation. It's very interesting because you can actually really kind of fine-tune them. For example, you've probably seen glue-lam beams, which consists of a bunch of 2-bys laminated or glued together. But what's interesting about it is that you know how in steel a wide flange works. There's a lot of material at the top. There's a long stem, which is the web, and then something at the bottom. Those are the flanges. And glue-lam works sort of the same way, where the best grade of lumber is at the top and the bottom, and the middle is kind of filler. The web, it just gives the depth, which gives a lot of strength. So you can literally engineer these products with, different grades of material in different places and different types to, perform in certain structural ways, which you can't do with something that just comes straight off the tree.
Mm-hmm.
Right. One of the reasons they're called engineered wood products.
Yeah, and I've seen some amazing glue-lam beams, with these incredible curves that you wouldn't be able to achieve with just one piece of lumber. So.
Very difficult, yeah. Right? Maybe impossible.
Yeah, a lot of waste if you did find something big enough. So,
So when were you first introduced to mass timber?
Well, like a lot of things that have happened in my career, it was kind of accidental. I used to teach at Cal Poly Pomona in Southern California for many years, and I was the chair of the Department of Architecture, and the Dean of Engineering approached me and said, look, we have an engineering faculty member who's been working with the students to design timber bridges, but he doesn't think they look very good, and he wants, because engineers have been designing them, and he wants to work with an architecture faculty member. Do you think somebody might be interested? And I was like, I've always wanted to do a bridge design studio. So I said, I'm going to do it. So I started working with Professor Michael Gershfeld, and we had our engineering and architecture students working together in studio. And it was very, very, very interesting experience. For the engineers, they're used to like having a lecture and a quiz, and a design studio is a kind of barely controlled form of chaos, where things are happening. But what was so interesting about it is that they started working together in teams and really learning from each other. And architecture students are very creative, which means they come up with all kinds of very challenging designs. And what was so great about wood in a way is that you have to understand how wood works. Concrete and steel didn't kind of do anything, but so some things they were doing, we were already using glue-lam in it, but Michael knew about cross-laminated timber, which had been developed in Europe and really was starting to be applied from the mid-'90s. And cross-laminated timber is something I described as plywood on steroids. Basically, they take, 2x and lay them out one way, and the next layer goes perpendicular, and then the next layer goes. So it spans very far in two directions. And he said, there's this material, and it's very strong, and we could use it for decking on these bridges, and then it would have a lot of lateral strength and work as a diaphragm. So I was introduced to more advanced mass timber projects back in 2009 or 10. And then I was recruited to come up here to head the department at University of Oregon by an old friend of mine who was the dean. And I never really expected to leave Southern California, but stuff happens. And Michael Gershfeld, my partner, knew people in wood science and engineering and in engineering up here because there's kind of a small engineering timber community. So I made contact with them, and the dean of the former dean of the College of Forestry, Dean Thomas Manis, had decided it was time to start producing cross-laminated timber and other mass timber products here in Oregon, be the first in the U.S. to do that. So he asked me, he said, we need architects because architects decide what goes into the building. So he asked if I wanted to work with him on this project. I was like, yeah, sure, sounds good. So anyway, he assembled in November of that year, like everybody in the timber community, state loggers, timber owners, forest, in the state for a big summit. And Valerie Johnson from D.R. Johnson decided to take the plunge and start making CLT. And we went to the legislature, and in 2015, they started funding the TallWood Design Institute. So I kind of started accidentally getting into it, but, I got up here, people were excited about it. So suddenly here we are doing, we've done like 100 research projects in the last 10 years. So yeah, it's been really amazing. Mm-hmm.
Wow. Mm-hmm. So the TallWood basically came from that, from there. And then that was one of the first in the United States.
Yeah, Valerie Johnson actually produced the first structurally certified CLT in the U.S. SmartLime had been making it up in one of the northern states. It's embarrassing. Minnesota? No, Montana. It was Montana. Anyway, sorry about that. Whole middle of the country is a mystery to me. So up in Montana, but they were making it for temporary road pallets, which is kind of a use for it. They didn't get it structurally certified. So Valerie Johnson's was the first structurally certified CLT.
Wow.
And then SmartLime was like, maybe we should think about structurally certifying it. So it really was the beginning. And then Freres, would making plywood for a long time, were like, we make plywood. Maybe we can make massive plywood. And in both cases, they started working with faculty both in engineering and within forestry. There's a department which is wood science and engineering, which is multidisciplinary. It's very interesting, but they started working with some faculty there, some of whom were engineers and some of whom were wood scientists who helped first Valerie Johnson develop her press and plant, and then they worked with Freres to develop the mass plywood material. So we had lots of stuff going on here in Oregon, and then, people started building buildings out of it, and it really started taking off. And we are still, I think, the most productive, active research institute in the U.S., and partly because we have state funding and state support, because they see, timber is still huge in Oregon. You must know that, right? Like Washington has a lot of timber. We're still the biggest, softwood lumber producer, but they also have a lot of other industries. And Oregon has not that many other big industries. Timber is still incredibly important. So the state saw an opportunity to get more value out of timber products by turning them into higher value mass timber products. And they also saw a way to actually source small diameter logs and use them in mass timber products, and as a way of making forest management more sustainable, so that you thin the forest, you take out smaller diameter logs, making it healthier, less prone to wildfire. So the idea was both kind of sustainable forest management and economic development simultaneously, and that's really been the focus.
So are mass plywood panels the newest type of mass timber invention, would you say?
They're one of the newest. I know that Boise Cascade is now making something called VLT, which is veneer laminated timber, which is similar. They're making smaller panels, and people are inventing things all the time, composite panels and panels that, we're starting to look at timber panels that have sensing devices in them that are kind of smart panels. So I think it would be fair to say there's new products coming out all the time, but in terms of like being used a lot in big buildings, it's really CLT and mass plywood. Those are the two big ones. Yeah.
Mm-hmm. And the mass plywood panels, are those used mostly internally externally, structurally?
Structurally. In general, these panels are meant to be structural components. If you put them on the outside of a building, you really have to clad them, right? Because you really want to protect the wood. You can put coatings on, but it's really better to, put cladding on them. But they're used for structural components of all kinds. Columns and beams, floors and ceilings. They're meant to be structural components and used inside a building, to build a building.
To build a building, which you have done. Tell us about the mass timber home.
Right. So we're working on, we actually completed our first prototype on a little project we've been working on. Seems like forever. I'm an architect. I practiced in LA for 25 years, and I keep joking that, why it would take 4 years to design a little house seems crazy, right? You should be able to do that in, a week. But we've been looking at using very thin mass plywood panels, 3-inch for the exterior of the building and 2-inch partitions for a little house, because we're trying to see if we can make a mass timber house compete on price with lightwood frame, which is typical and the cheapest way to do it. And you might wonder why we want to do this, because mass timber has all these other benefits. It can actually, form a commercial market for small diameter logs, making forest restoration have a commercial market, which helps defray the costs of it. It can create more jobs in rural communities by creating more demand for more mass timber products, more jobs, more income in rural communities that really need that, logs and income, jobs and income. So, and it's also that the material is very resilient. In terms of fire, it will char and then stop burning. So it's much more resilient than lightwood frame, which is like kindling in a fire. Just will blow up. It's also, even though it's heavier than lightwood frame, it can be made to be very resilient to seismic forces, meaning it can move and then come back and basically be undamaged. So there's you can make a much sturdier building. And also, because you fabricate it using computer-controlled machines, you make very precise cuts for windows and doors, which just pop right in. You don't have to shim them. There's no leakage. So they make a very tight thermal envelope, which means you also have minimum heating and cooling bills. So we think that if we can get it to be about the same cost as lightwood frame, and it has all these other kind of much more resilient benefits, and it can help make healthier forests and reduce wildfire risk and create jobs in rural communities, it's like a win for everybody.
Wow.
So we've been looking at this for a long time, and we started working with the city of Milwaukee right outside Portland, because they were working to change their zoning code to comply with HB 2001, which was passed a few years ago by the legislature, which essentially eliminated single-family zoning in any community with a population over 10,000. So they were looking at, because of urban growth boundaries in Oregon, right? You have to densify for more housing. So they were looking at making it possible to make what are known as cottage clusters in single-family house lots, which are collections of small houses around a courtyard. So we started working with them to develop a little 2-story, 2-bedroom house that would have a small footprint, not be too tall, where you could put a whole bunch of them around a courtyard, where you used to just have one house. And that's the model we've been looking at. And we chose to make this type because it seemed to be the one that would have the most appeal to the market. We consulted with a bunch of affordable housing developers. And also, it can also be used for an accessory dwelling unit or just a small freestanding house. I mean, it has a lot of utility. So we worked on it for a while, and then we started working with the Port of Portland, Business Oregon, the Department of Land Conservation and Development, and the Oregon Department of Forestry, and TallWood, and the 2 universities, UO and OCU, to get this very big Economic Development and Administration Build Back Better Challenge grant, which is very exciting. That's paying for a lot of things, including 2 new labs, an acoustic lab, testing lab for us, and a fire testing lab for OSU, but it gave us money to actually start prototyping this little house, building full-size ones. So we're working with an engineering team, including Michael Gershfeld, the professor who eventually got me involved in this.
Full circle.
Yeah, exactly. And we got to do, real engineering drawings. We're in a real engineering firm, which it's in Southern California, which seems weird, but the principals in the firm are former students of Michael's. So they usually work on giant, complicated projects, but they like the idea of working with Michael on this little, tiny, complicated project. So they've been great. So we managed to do the engineering. We did a lot of design, a lot of work on how to integrate the mechanical systems and plumbing and electrical. And we finally got the first one up late spring and summer and had about a zillion people touring through it, which is very exciting. I was very nervous about how people would feel about living in an all-plywood house, but the response has been like overwhelmingly positive. But here in Oregon, we love wood. We love wood.
Yeah.
So now we're working on optimizing. We learned a lot of lessons, and the second one is going to have less steel connections in it, which is going to take out some of the cost of it. And we were doing the panels sort of horizontally, what's called platform framing, building one story at a time. We're actually going to try doing it with vertical panels, 2-story panels. It's going to be a little harder to build, but it's much better structurally, and we can use fewer panels. So we're going to compare those costs. And while our research faculty and graduate students built the first one just to kind of test it, we're going to be hiring a contractor to do the actual fabrication and construction because we know what the materials cost. What we don't really know yet is how much the fabrication and the labor of construction cost. And then once we get that done and decide, if that's the right direction to go, we have a pilot project of 4 units lined up in Eastern Oregon with a private-public partnership called R3. I think it's Rural Regenerative. I always forget the third R stands for. But they're doing a bunch of housing out there, including cottage clusters. And a guy named Nick Green we're working with, who's very enthusiastic, and we're going to do a pilot project of building 4 of them out there in a little cluster. And we're hoping to get more pilot projects because the second prototype we're going to do outside the lab at Emerson to test thermal and acoustic and lots of properties. But getting one done in the field that people actually live in, that's going to be another test, and I'm sure there's going to be further refinements from it. So, yeah, it's been a very interesting project. It's taken a long time because somebody asked me, how is it different from building with a light wood frame? And I was like, in every possible way. It's like, we don't have hollow walls. We can't hide any services in them. The structure is completely and totally different. There's so many things that are different about it. But we're very optimistic, actually, that we can make it compete on price with light wood frame.
What is the average square feet of one of these homes that you're testing out?
Yeah, so it depends what you count, but out to out, meaning there's a ton of insulation in this, right? So out to out, it's about 888. Inside, it's about 750.
Okay.
And it's a 2-bedroom.
Okay.
Yeah.
And 2 stories.
2 stories. Bedrooms upstairs, bath and a half. We have a half bath downstairs with kitchen, dining, living. Upstairs, 2 identical bedrooms, a full bathroom, and a laundry closet for a washer dryer.
Feels like you were really optimistic by doing a 2-story to start with.
Much harder than a 1-story.
Yeah.
Much, much harder, especially because we decided to do platform framing and build it 1 story at a time. That made the engineering much more difficult, which is why and introduced much more steel than we thought. I mean, steel is expensive, especially, it's going up. So, we decided, though, that we had to do 2-story because that's really what works best in cottage clusters. And frankly, a lot of people, if you want to live in a little house, you kind of like the idea of some separation. And on the upper floor, we can take advantage of the gable roof and create some shapes and clear stories, some light above kind of the closets that goes through the house. So, but the 2-story is a little bit more challenging structurally, and maybe more than a little. But with the vertical panels, the engineers are like, yeah, that's much easier. But it will be a little bit harder to construct because, we have to put up the walls and shore them and then drop the floors in. But, we're going to find out how difficult that is. Yes, it is much harder to do 2-story than 1-story. It's totally true.
So that the test project that's happening out in Rural R3 out in Eastern Oregon, is that going to go on sale to the general public, and then you guys are going to follow along and see how it goes? Or?
Yeah, I assume that those are going to be for sale out in Eastern Oregon, where there's very little available housing. And I think actually we might be getting one of our faculty members at UO who does a lot of post-occupancy studying of housing to do the post-occupancy study. It's not really our specialty, but we have faculty who specialize in that, interviewing clients and finding out, how well it's working for them. And that's something we're really curious to see.
Totally.
How that goes.
Yeah.
And if their mental health went way up just living in this wooden home.
Well, there are a lot of studies about biophilia in wood. You probably know that there are a lot of studies, mostly in working environments in schools, that people tend to be more productive and have fewer sick days. So when we had the open house, Marcus Kaufman from Oregon Department of Forestry does a lot of communications for our group. It's the Oregon Mass Timber Coalition, the group that got this big camp grant. And he decided to do a kind of person on the street interviews with a lot of people. And one of the people he interviewed said, "I like the way it smells." Right.
Yes.
Which is we were so happy about that.
Yeah.
Yeah, and the person who said it, I can say, is Margaret Van Vliet, and she used to be the head of the Department of Housing and Community Services for Oregon. So,
Wow.
So she knows a huge amount about housing and housing legislation, how everything works, but it was just so funny that she said, "And I like the way it smells."
Yes.
On top of everything else, that's another added,
it's a benefit.
bonus.
Yeah.
You'd have to think that, obviously I'm not a contractor, but you'd have to think that when you're building a house and it comes in panels, that would be easier than framing a house with
On site.
Yeah.
It should be faster.
Right.
The one complication is that you don't need a full-size crane. We think you just need what's called a small telehandler because the scale is so small. So you do need to know how to use that, but it's not rocket science. But it should go up, all the panels should go up quite easily in a day. That's the idea. You still then have to do some, adding plumbing and electrical, but there are no finishes right inside. You do have to do, we originally thought we were going to ship the panels with insulation and cladding on them, but we decided not to do that for a variety of reasons. One, they could get damaged in transport, but it really meant that we had to do all the connections on the inside of the house, and it exposed a lot of steel connections, which, architects like that, most people don't want to see that. It's also, they were expensive steel connections, so now we're just going to ship the panels, and typically in fully volumetric modular, when they make a whole box and ship it out, they do the insulation and cladding in the field anyway. So the insulation and cladding has to go outside, but inside, the panels are done. But we're very interested to see about how, installing, electrical and plumbing will go in the field, because, again, we're going to have to get electricians and plumbers who have never dealt with this. Well, the plumbing is actually pretty similar.
So you have the panel and then you have the insulation and then you have a typical sheetrock wall on the inside or you have another panel?
No, on the inside we have nothing. We just have the exposed plywood panel on the inside. We're actually treating it with a whitewash. So Timber Pro, a company in Portland, makes a kind of wood finish. And we did, they have what's called a PDX white because that's what they used at PDX, right? But we experimented with adding more, essentially paint to it. I chose a paint that has a little bit of yellow and a very high reflectance value because the wood starts out a little dark and, it tans when it's exposed to sunlight. So we wanted to do something that would make it lighter and brighter. So we did 300%, mix compared to what they usually do. And it could go on in one coat. So that is the only finish. And we did some tests. I didn't do them, but we have one of our UO labs does all this stuff to test the reflectance value before and after the whitewash, and there was significant improvement. So that is the only finish, and that can just be sprayed on very quickly, and we might even pre-finish them. So it's really on the outside, you put a vapor barrier, insulation, and cladding, and that's it. The whole idea is that there's no interior finish. There's no gypboard, and one of the reasons we don't want to use gypboard is it has a very big carbon footprint, which is, we're trying to use material that does not have a big carbon footprint, right? So, so no gypboard, no finish, no paint, little paint in the Timber Pro, but.
Interesting. And so that's where the Ferris panels could come in, those beautiful new panels that they have.
That's what we've been using.
Displayed.
We're using Ferris panels.
Because Chelsea and I went to a panel discussion at Skanska, and they were talking about the Albina project and how can be some hesitancy to live in a plywood home. And if you can see the plywood on the inside, doesn't feel the same. And so those Ferris panels are just gorgeous. And then you have that on the inside of your home instead.
Yeah, we actually were very concerned about that, about how people would feel about being in a plywood house. But we've had lots and lots and lots and lots of tour groups go through. For the open house, we had over 120 people. And actually, we didn't even start counting until half an hour in. It's like, how many people are here? Right? We had something like 75 people RSVP. And usually when people RSVP, half of them don't show up. But we had many more people show up. And the response was overwhelmingly positive. I mean, a couple of people said, well, could you paint it or put up wallpaper? I said, you could do that. Painting plywood never looks good. You could put up wallpaper if you really want to, but very few people had an issue with it. Most people are like, this is great, you know. And the video of the open house shows people like with their iPhones out everywhere, all over the house. There's a number of interesting details. For example, all the doors, they're just all the interior partitions are just 2-inch MPP, even thinner than the walls, which are 3-inch. So the doors are just a pivot door, meaning we don't have to make a frame for them. They're put on a pivot hinge, and they just open and close. And even though they're a heavy 2-inch panel, they pivot very easily. And we found some very inexpensive pivot hardware and a little $5 ball joint. And they actually work very well in terms of soundproofing, far better than we actually expected. But it meant that you don't have to do the framing of the door because the cuts, the CNCing of the openings for windows are so precise. All of the windows went in about an hour. It's like pop, 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 pop. So certain things, because of that, are quick and easy because of the precision of the fabrication.
Wow.
Yeah.
So if we wanted to see one, is there another open house, or how are you displaying this somewhere?
We actually had to disassemble it because we assembled it inside the Emerson lab on the strong floor, and we have many, many more projects that need that space. But we're doing a second prototype, which should be up this summer, which will be outside on a big concrete pad we have out there. And we might keep that up for as much as a year because we want to do energy testing over time. We don't do acoustic testing, indoor air quality. There's a bunch of tests. So there's less demand for the outside location, so we think we can keep that up for longer, and we're definitely going to have more tours. What's so funny about it is that, it's not everybody who works in the lab, we're doing tours. Dean Thomas DeLuca, who you've talked to,
Yes.
he was conducting tours. They had, a giant tailgating party, and I was asked to provide a little bit of text for Tom to read because they were doing tours. They asked me if that was okay. I said, do not take incredibly drunk people to the house. Make sure they're just a little bit sober, but yes, that's fine. So I'm like, tailgaters,
Yeah.
But it's like everybody, and it's so interesting is that, in the lab, we usually, have these big structural things. We're breaking things and doing things, and people say, oh, that's cool. But when you see mass timber in a house, and we actually furnished it. We actually have living room furniture and dining room furniture and beds and all that. It's completely different. People can really imagine living in it. And that was somehow much more exciting to people than just watching structural testing and fabrication. So, oh my God, I could live in this house.
Right.
So,
You
yeah.
want to feel it. It's like, it's like any open house. If you're buying a home, you want to see what it feels like.
Exactly. It's like any open house.
Is the Emerson Lab U of O or OSU?
OSU. It's at the College of Forestry.
You know what? We were there and we saw it. We didn't get to go inside. We were doing a tour. Remember?
I don't think I was.
Oh, you were
On that.
on maternity leave.
Yeah.
I think
When
I
was
saw
this?
it.
When was this?
It would have been September.
Yeah, it was up in September.
Yeah.
Yeah. So you saw it was like a big plywood box.
Yes.
Up. You should have gone inside.
Dang it! I was so close.
Yeah, right.
Shoot. And
Should have gone inside. Everybody's been inside that house. The lab staff use it as a lunch lounge, as a meeting table. They meet around the dining room table. They meet on the couch. I mean, everybody misses it now that it's gone, right?
Yeah.
Yeah, you probably
Dang
saw
it.
it, the big plywood box.
I think I
yeah.
have a picture in front of it.
You don't
Yeah.
know
I can't-
what you got till it's
You should have
gone.
gone inside. It's very different inside because inside it's whitewashed and has furniture. But the outside one, we should have it up by this summer. And we'll have a lot of tours of it.
At Emerson as well.
Yeah, it's
Okay.
going to be outside in the yard so that, again, we can do thermal testing and all that. And also, we want to do daylighting because, we've got all these skylights, but, we don't have sun in the lab, right? So we do have, electric light coming in, but we want to see what the daylight looks like, outside where there's, sun, right?
Right.
So there's a whole, and the lab that I work with at UO, Energy Studies and Building Lab, does lots of performance testing. They do acoustic, they do energy and thermal, and indoor air quality, and all sorts of data gathering exercises, and which I don't particularly do, but we have incredibly talented, smart faculty who do that, and they will be gathering a whole bunch of data on the house to see how well it performs.
Wow, that's awesome. Yeah, let's
Yeah.
go do that this
Yeah.
summer.
Yeah.
Judith, you have to invite us. Tell us when it's there.
I will be doing that.
Okay.
Or you can just, email me and nudge me about it, right?
Okay.
It's
Yeah.
like, is it ready yet?
Did you build the house yet?
Yeah, right.
This has been fantastic. Thank you so much. We this is I learned so much, and it's just
good.
it's exciting to see what's coming and what's been done, and then improving upon it and making it a reality for people. And these people in Eastern Oregon don't even know.
No, I have
Hope they
one
like
more
it.
one more
Yeah,
question. Out on the show floor, you guys had this robotics arm. It looked like an arm.
yep.
Can you talk about that real
Sure.
quick? What was that?
Yeah, so we have a very large number of projects going on, as you can imagine. So Dylan Wood, who's an assistant professor, who I actively recruited, does amazing work. I'm sure you saw the giant hollow tubes.
Yes.
It's a project he did with his students. So Dylan does a lot of very interesting things with sort of self-shaping of wood, where you wet it and it starts to curl on its own. And those are these big hollow tubes. Anyway, he does all kinds of very interesting work, but he also knows a lot about robots and digital production and a lot about wood. So he's working with Ross Hatton, who's a faculty member in the OSU robotics department. And they talk to Timber Lab, which of course is out there and does all this work. We work with them all the time. Dylan had some ideas about some of the processes they use in fabrication that might benefit from robotic automation. So he talked to Chris Evans, who's the CEO, about 3 ideas. And the one that Chris was like, that's the idea, was developing a robot connection that can insert steel connections into columns and beams that have been digitally fabricated. Right now, that's a hand operation. It's hard, it's labor intensive and time consuming. And what they need is to develop, and there's no piece that does it now. What they need is a piece it's called material aware. I think it's going to have a vision sensor eventually so that they can precisely place these parts and, press them in at the right pressure. And they could do it once that process is figured out. It can be done very quickly without a lot of incredible, physical labor that they have to be. And right now, all the cutouts for those steel pieces can be done digitally on a big machine. But because that's still a hand operation and time consuming, the fabricators are like, that would be an amazing thing. So that's a research project that we funded and that's what that's demonstrating, is that's like a little tiny robot. That's like Dylan's robot that he experiments on things with. But his student Braden and Dylan set it up so that it demonstrates picking up, one of these connections. They're made by a number of people, Rikon and Knapp, and now Simpson's making them, but they're kind of male-female parts that kind of just snap together. And he's putting in one of those parts in something that's been CNC'd. So that's what the robot is doing. It's
Okay.
demonstrating how a robot could do that. It seems like, sure, a robot could do that, but it turns out there isn't a robot that can do that yet. And that is something that the industry really wants. And so Dylan has been working on that, as well as working on all these really big experimental things with how to do things with the natural properties of wood in a way so that you can use wood in the best way possible to use less of it for structural purposes. How can you use less wood and optimize it structurally?
Right.
So, yeah, he's sort of at the cutting edge of that. And, we have faculty doing all kinds of things. But, yeah, that's one of them. And, yeah, Dylan's doing all sorts of interesting work.
Wow, that's cool. So in a few years when we come, 5 years from now when we come to the show, there will be a whole probably demonstration on how far that's come and what it's doing.
Hopefully in a year or two. It should happen pretty quickly.
Robots move faster in the lumber industry.
Yeah, well, that is true. This is one of Dylan's point. He thinks that a lot of us are a little bit, dinosaurs. And that, there's going to be more and more automation. When you go to Frere's, they've had robots for quite some time doing things like scarfing and other things. And, so we really do in the forest products industry here need to start doing more in other words, we hope not taking jobs away, but taking difficult
Labor
intensive, physically difficult jobs, giving those to robots,
right.
and giving other kinds of more high-tech jobs to more humans, like running all those machines,
Right.
programming them. Yeah, right. So, yeah.
Awesome. Thanks for answering that.
Sure.
Before we wrap up.
Well, thank you, Judith. It's been great, and we're looking forward to it. And I'm going to find that picture of me standing in front of that house.
Yes, and we're going to come tour that house this summer.
Yes. Thank you for your
Look forward to
time.
that. Sure.